Hello everyone, welcome to lesson 10 for Calculus BC. This is the definition of area or Riemann sums. And just like before when we talked about derivatives, when I introduced you guys to derivatives, we talked about that related to the slope of the tangent line. Well, before we get into actual integration and how to integrate using fundamental theorem of calculus, we're going to talk about an approximation first. And so we're going to talk about how to find an approximation, and we're going to correlate that to area underneath a curve. Okay, and so specifically what we're going to do today is talk about Riemann sum, because that's a really good approximation for area underneath a curve. And really what happens here is we have a curve here, and we have it bound, and we create rectangles. We create a lot of rectangles. So the height of the rectangle, the height of every rectangle is going to be the corresponding y value. If we look at this like on a coordinate plane, if I said, okay, let's look at where C is, well, the height's going to be f of c. Right, f of c. And so if this had been d, then this would be, the height would be f of d. But it's always the y values of the function. And the width is going to vary, but the width is going to be obviously the distance between the two, well, the distance of the width of the rectangle, right, the width of the rectangle. And so let's actually start getting into some examples and talk about what we can do with this. So if you guys look at example number 1, there are 4 Riemann sums that we're going to learn. We have the left hand, the right hand, the midpoint, and the trapezoidal. And so example 1 says, by reading values given by the graph of f as shown in the table, use 5 rectangles to find a lower estimate and an upper estimate for the area under the given graph from the 0 to 10. And in any case, sketch the rectangles that you use. So one of the things we want to talk about really quickly is how to find delta x. Delta x, that's going to be the width of our rectangle. Okay, so that's going to be the actual width of the rectangle. This right here is the width of the rectangle. Well, we're looking at the interval from 0 to 10, right? So we're looking at the interval from 0 to 10. So in this case here, this is our A, and this is going to be our B. Okay, this is our A, and this is our B. So if we do this, this is going to be 10 minus 0. So the B obviously is the end point of our interval. This is the starting point of our interval. And then the N is going to be the number of rectangles. Okay, so N is going to be equal to the number of rectangles, and they're going to give that to you. So we're going to have 5. We're going to have 5 rectangles. Now, this is assuming that delta x is constant, right? So there's going to be a couple of examples that we're going to do later in this lesson that it's not going to be constant, but for right now, we're starting out very simple. So delta x is actually equal to 2. Okay, so 10 over 5 is 2. So what happens here is this. So I'm going to use a lot of color with this. So here are the values that you guys see for the table, and they've already plotted them for us. So they've nicely plotted them for us right here. And here's our function, y equals f of x. So this is all that you have to do. So at 0, y is 1, at 2, y is 3, and so on. So left hand Riemann sum. So this is what we're going to do for this. So the first one, because delta x is 2, our first rectangle is going to have a width of 2. So we're going to start at 0. We're going to start at 0, and we're going to go ahead and go 2 units over. So that means that our width is going to be 2. Since it's the left Riemann sum, what we're going to do is, now that we have our line here, we're going to go on the left side of it, and we're going to go up till we hit our actual curve. And so we hit it right here. And then we're going to go ahead and make ourselves a rectangle based on those 2 values. All right, so our delta x is going to be 2, and then our height is going to be the height at 0, because we're going on the left-hand side. So that's our very first rectangle. And then we're going to go ahead and do the same thing for the next one. So again, we're going to go from now 2 to 4. So our rectangle has a width of 2, and because we're, again, a left Riemann sum, we're going to go on the left-hand side, and we're going to go up to where we hit our curve, and then we're going to create ourselves another rectangle. So I always tell students, once you go right here, just go ahead and go right, 2, and then go back down and create yourself a rectangle. And hopefully you guys can see what we're doing here, so let's continue on with this one. So the next one is going to be another 2. So now this is from the interval from 4 to 6, right? And so we're going to go ahead and go up to, we hit our curve. It's okay that it's not exactly on our line, right? Okay, it's totally fine. And then we're going to go ahead and make ourselves another rectangle. And when I do the right Riemann sum, guys, I'm going to obviously go a little bit faster with this, but, we're good. So again, now from 6 to 8, or just 2 units, I'm just adding 2 right here. And now I'm going to go up again the left-hand side till we hit our curve, create ourselves another rectangle. And eventually, you guys, I'm going to show you shortcuts where you don't have to do this long drawn out thing. And then 2 more, and that's perfect, because again, 2 gives us 10. We go again on our left hand side, because left Riemann sum, And then once we hit our curve, we're going to go ahead and draw ourselves another rectangle. Okay, so now we have done our rectangles for left Riemann sum. Now guys, I just want to say really quickly, and we're going to talk about approximation here in a minute, but notice that this is going to be an under approximation, right? Because I got this area, then I'm not taking into account this area, this area, and this area, and this area right here. So all of these are underneath the curve, therefore this is going to be an under, but we're going to get to that a little bit later on. So what I want to do now, ladies and gentlemen, is I want to actually find the areas of these rectangles, right? I want to find the areas of these rectangles, and I want to add them up. And then when I add up the sum of these rectangles, that's actually going to give me the approximation of what I want for this actual, for this Riemann sum. Well, remember that delta x for this first one, this purple one right here, it's going to be 2. That's our width. And remember the area of a rectangle, again, I'm not trying to insult anyone's intelligence here, but the area of a rectangle is length times width. So this is going to be 2. And now the height is going to be the y value on the left-hand side, right? We went from 0 up to this value right here. Well, in our chart right here, this y value is actually 1. So the area of this first rectangle is just going to be 2 times 1. And then I'm going to go ahead and do plus, because we're going to add these areas up. Again, this width of this one is going to be 2. And now the height of this rectangle is the corresponding y value at 2, right? We used the left-hand side of this pink, and we went all the way up to the y value. So when x is equal to 2, when x is equal to 2, y is going to be equal to 3. So this height is going to be 3. And these two examples, you guys actually can count the blocks, right? You can see this is 1 block. This is 1, 2, 3 blocks. So we can kind of do that even without the chart. For this next one right here, the orange one, we have our width is 2. So again, we're just finding the area of each rectangle, right? Length times width. Very simple stuff. And then we use the left-hand side. So we use the 4, right? So we use when x is equal to 4, we went up to our curve. Well, when x is equal to 4, our y value is 4.3. And then we can do the same thing with the green one. Again, our width is 2. And then we're going to look now on at 6, right? So between 6 and 8, we use the 6 to come up to our green value. So at 6, it's 5.4. And then the last one, ladies and gentlemen, our width is going to be 2. Right, this width is going to be 2. And then we used the left-hand side of our interval. So we used 8 in lieu of 10. And so at 8, we're going to do 6.3. All right. And so we're going to go ahead and we're going to use our calculator here, and we're going to add these values up, and we get that this is 40. We get that this is 40. So the area under the curve, approximately with left Riemann sum, is going to be 40. Okay, it's going to be 40. So what we can now say about this is a couple things. One, again, it's an under approximation, right? It's under approximation. And we'll talk more about that a little bit later on. And the other thing is that there could have been a shortcut here. Right? Hopefully you guys realize that I could pull out a 2 for all of them. So when delta x is constant, we can actually pull out our delta x for all of them. So I could have essentially pulled out a 2, and then notice the numbers that I added. I added 1, 3, 4.3, so I got 1 plus 3 plus 4.3 plus 5.4 plus 6.3. So this is my shortcut, and notice that those are the 5 numbers on the left, right? So I've got 6 numbers here for f of x. These are the left numbers of my chart. So that means I'm going to use 1, 3, 4.3, etc., the left numbers. So that is a shortcut that you guys can use, and we're going to do the shortcut over here as well. But that's a shortcut you guys can use without drawing all of those rectangles and do that. But again, this only applies if delta x is constant. Okay, if delta x is constant. So let's go ahead and now look at the right Riemann sum. All right, the right Riemann sum, and let's do these rectangles. So let's talk about them. So again, ladies and gentlemen, we're starting out here at 0 to 2. Now the difference is that now we're on a right Riemann sum, so I want to be on the right side. So I'm going to go up on the right-hand side, and then I got to my curve, and then I'm going to go ahead and create myself a rectangle. So you guys can see that this is already going to be an overestimate because I'm using stuff that's above the curve, unlike what's over here. And so we're going to keep on going with this one. Again, we have our 2. We're going to go up on the right-hand side. We're going to create ourselves a rectangle and then come on down. We're going to keep on going with this. So 2 up on the right-hand side. We create ourselves a rectangle. And then we're going to do this 2 more times. Pretty straightforward. And again, you guys will do a little trick here for this one. And we'll do some examples, not in this video, but we'll do some examples about what happens when delta x is not constant. And if it's not constant, I can just tell you guys right now, you just have to find each individual rectangle specifically. So maybe delta x is equal to 3 instead of 2. You just got to find this separately. So it just takes a little bit more time. But here, so here's all of our here's our rectangles, and notice that we have covered literally everything underneath the curve plus a little bit more. So we can go ahead and say that this is going to be an overestimate, right? This is going to be an overestimate. But just like before, let's go ahead and use our shortcut, right? Let's go ahead and use our shortcut because we can, because delta x is constant here as well. So I can say that the width of every single one of these is 2. So I can go ahead and just pull out a 2. And now all I need to do is add the heights of these things. So remember, for this purple one, the height we used at when x is equal to 2, right? We went up on the right-hand side. So we're going to use 3. So the height of this one, again, this is a really good way for you to count 1, 2, 3. And I'm going to go ahead and add this one. For this one, we used actually 4, right? We went up on the right-hand side of 4. So 4 is 4.3. And then for the orange one, we went up on the 6, right? We went up to 6, which is 5.4. Green, we went up on the right-hand side of 8, which is 6.3. And then red, we went up on 10, which is 7. And so for this one, I get 50. I get 50. So the actual integration is somewhere in between 40 and 50, right? It doesn't have to be directly in the middle. It's not, but it's somewhere in between 40 and 50. So we know that the actual approximation, the actual integration is actually is between 40 and 50, but we'll get to that a little bit later on as well. And guys, just like before, notice that the numbers that I chose on the right-hand side were, again, out of the 6 that we have, I chose the 5 to the right, 5 to the right. And so that's another way of thinking about that. So we're going to do another left and right-hand Riemann sum here in a second, but that's just an introduction of what's going on here. It's pretty basic. And just really quickly, how do we know that was over or under? So ladies and gentlemen, this is what's going to happen. If it's strictly increasing, as you guys see right here and here, if it's strictly increasing, if you go ahead and you draw a left rectangle, so left Riemann sum, you're going to always be on the curve, and then you're going to have, oh, that's a horrible straight line, and then you're going to have left. It's going to be the left of the corner of this now weird looking rectangle is actually on the curve, right? So the left-hand side. So it's always going to be under. It's always going to be under, sorry. It's always going to be under. And if I were to go and draw a right-hand rectangle, so again, the right-hand side has to be on the curve, it's going to always be over. And again, I apologize for how these rectangles look. So it's me right. So this is how you always do this. So if you are strictly increasing, if my graph is strictly increasing, and it usually tells you that it's strictly increasing, then your left-hand Riemann sum is going to be an under, and your right-hand Riemann sum is going to be an over. So sometimes I have students literally say, okay, let me just draw something. It doesn't matter if it's concave up or concave down. If I look at this one, my left is going to be underneath it. And if I look at this one, even that's harder to see, my right one's going to be above it. All right, it's going to be above it. Or I can do something like this, right? There's a right Riemann sum right there. If I'm strictly decreasing, so again, if I do a rectangle and I want this to be the left corner has to be on it, then I have to create it like this. I always tell students you always create from left to right, right? So there's my left, and if I want to do a right Riemann sum, then I want to go, on this side, I want to go right to left. And so this is going to be under. So right is going to be under and left is going to be over. So sometimes it's just as simple as drawing the picture. So I can go and do something like, strictly decreasing. I can go something like this. And let me change the color up so you guys can see it easier. So if I go left Riemann sum, right, left Riemann sum. Did I even change the color? That's orange and red, so they look really, really similar to each other. But a left Riemann sum is going to be over, and a right Riemann sum is going to be under. Okay, because the right corner has to be on the curve. The left corner has to be on the curve. So that's all you have to know for that. So I'm going to stop here for this video. We've talked about a left and a right Riemann sum. In the next video, we're going to introduce midpoint and trapezoidal, and then we will do some examples. So I'll see you guys back in the next video.